Here we go.
What up, my printer peoples? In this video, I'm going to be showing you how to take the Mark 11 micro quad frame and put all the electronics in it so that you're ready to fly this thing. If you have not seen the video previous to this where I explain this frame and why it is the way it is, you can click up here. And if you're caught up, then let's go ahead and take this frame over to the bench and start putting some electronics into it. All right, now let's take a look at all the electronics and how they're going to fit into the frame. This frame is designed around the F3 Evo Micro Flight Controller. This is what you're going to need to get if you want to make this work well. And the key with it is that it just fits very tightly and snugly into that frame, and you know it's going to work. If you get another flight controller, I don't know if it'll fit or not. That's going to be your deal. Also, this flight controller comes with a micro lossy connector or a Walkera connector. The difference between those two is the polarity. So just be careful whenever you're getting this type of connector that the polarity matches up with the designation on the board and the battery. You just want to make sure you don't accidentally reverse polarity on something. Now this is the Tiny FrSky receiver. Depending on what type of transmitter you have, you're going to get the corresponding micro receiver. Now this one is just small enough to fit into the frame, and it works with my FrSky Taranis. So this is the one of choice for me. Also, these are 8.5 by 20 millimeter motors. These are brushed. These are very easy to find on Amazon or eBay or Banggood or wherever you want to go. They're not very expensive, and there's a bunch of different companies that make them and a bunch of different versions. Just try to find one that's powerful and has good reviews. The beauty of this frame is it can accommodate a variety of different cameras. Now the new hotness that's out now is this. This is going to be the smallest and lightest micro camera and VTX all-in-one. That obviously fits very well on the frame. Now it also accommodates the bigger, this is the VTX or TX02 from Yixing, and that also fits on here with the cloverleaf. The props will clear it, no problem. And then also this is a TX01 with a whip antenna, and then that also fits on there quite well. So it accommodates kind of any size of these micro FPV backpack type cameras. And you're gonna need a couple rubber bands. These will be used to wrap around the frame to hold the battery on the bottom. All right, so let's take these motor mounts and prepare them to go in. And one of the things that I like to do is to pinch the motor mount where you can feel there's a seam from the 3D printing process, and just cut a small little wedge, not too big, about that size, off. That way the wires can come from the motor, and then they can go out of the motor mount and into the arm. Each of the V's from the motor mount aligns up with the holes in the arm. All right, so next let's get the motors in. Now, whenever you have a quadcopter and it's facing forwards conventionally, you have the top left and bottom right motors as clockwise spinning, and the other two motors as counterclockwise spinning. Now, these motors with red and blue wires, this is kind of a convention on brushed motors, that means that this is a clockwise spinning motor. So we'll slide the motor into the motor mount, like so. Now make sure you don't push on the shaft of the motor to seat it. You want to grab the sides of it and push it all the way in. You don't want the motor to push this back plate out. So if you push on this shaft, that plate will pop out. But once it's seated in the arm, then you have to be a lot less careful with pushing that shaft. Like when you're putting on props and stuff, you can just push the prop on, not worry, because the way this arm supports that back plate. All right, so we're gonna have our twisted pair of wires, and we're gonna go ahead and just make sure that the ends are close together so it doesn't get caught in the tube. And once they're, looking good, you can just kind of slide it in like this, and you just might have to fiddle with it a little bit, but it should go very smoothly. And at this time, it's good to have a pair of tweezers. So I'll flip this over and I'll just grab these. And what I'll do is I'll pull, but I'm also going to watch up here as I'm pulling down here so that I don't pinch these wires. You want to make sure that everything kind of smoothly goes in. And you can kind of come in here with your tweezers and massage these connections so there's no kinks. You want to make sure that there's no knots or any stress bends or anything in these wires so that they'll last as long as possible. So now we're going to go ahead and do that for all 4, repeating the same process I did on this one. All right, now that we've got the motors in the frame, let's push that over to the side and take a look at the 2 circuit boards we're going to be playing with, the flight controller and the receiver. Electrical tape here to make sure that no connections or short circuits occur between the 2 boards. All right, there's going to be 3 wires going from the receiver to the flight controller. And if you look at the flight controller, we've got 3 UART channels. We've got UART 1, UART 2, and then UART 3 on this other side. We're going to be connecting the ground 5-volt and receiver pins from UART 2 to the corresponding, let's flip this over and see. Right, so we've got SBUS and PPM, so we want to be using the SBUS row, and then we're going to be doing the signal out and then positive, negative. The antenna actually sits inside and is protected as well and kept straight. So what we're going to do is I'm just going to kind of poke it in that hole, and then I'm going to use my tweezers to kind of feed it in just like that. You want this dip switch and this momentary switch to kind of be about right there. Okay, so that looks about right. A good tip to remember is that the flight controller has these white arrows that point forwards. The forwardmost of every single one of these motor wired pairs is ground. So we've got ground positive for motor 2, ground positive for motor 6, ground positive for motor 1, and so on for the rest of the board. Once we get the motors mounted to the flight controller and the flight controller and the receiver mounted into the frame, then we can go ahead and take some of that double-sided sticky tape and cut some squares out of it. Those squares will sit atop the standoffs that are printed into the frame, and then we'll press the flight controller down, mounting it securely to the sticky tape. So to mount the FPV camera, we only have 2 wires. It's pretty simple, but there's a lot of ways to connect it, a lot of options, I should say. I just want to warn you to not use these unless you're actually connecting a DSM satellite receiver. Otherwise, and these 2 are for the buzzer, so I wouldn't mess with those. So what I would suggest is just pulling from ground and the 5 volts on UART 1. Now our VTX has power. Now we get to do one of my favorite things about this frame, which is putting on the power connector. It's very simple. I always put ground facing forward, poke it through, push that in, and then bend this over. And I just kind of make, my wires routing really clean. I'll leave a little bit of extra room. I'll cut that one, and I'll try to keep them even. I'll cut that one. Okay, everything's in place, so now let's go ahead and get it ready to put the rubber bands on. I like to put a small piece of foam behind the VTX because there's a little display, and that display acts like a little bump, and it's not equal on both sides. So I put the foam in there just to make sure that the camera doesn't get pushed off to one side. Once the foam is in place, I go ahead and take the rubber band and I put it on top, and I go underneath the camera. I come to the round to the top and I twist it here, and I bring it back on top of the camera like that. That way the camera is held very tightly in place. The rubber band is making a cross on the top of the flight control board, and it's making 2 lines on the bottom side. When the battery gets pressed against this, it helps the battery not slide around. And then I take the next rubber band and I go across the middle of it, and I make the cross on the top. So then we've got 2 more lines going perpendicular in the first 2, and these are the 2 that you put the battery underneath, and that holds everything nice and tight. All right, so before we bind the Mark 11 to the Taranis, I'm gonna explain to you what this dip switch is doing. Now you see here it has a 1 and a 2. Now if this 1 dip switch is up and the 2 is down, you're in SBUS. If it's vice versa, so we push that 1 down and 2 up, we're now in PPM. But we want to use SBUS, so we're going to have 2 down and 1 up. Okay, let's go ahead and set up the Taranis so we can bind it to the micro quad. Also, when we go plug it into the computer in BetaFlight, we have got the arming and flight mode switches already set up. So we're going to go ahead and go to menu. We're going to create a new model. We're going to go over to the quadcopter. We're going to say we want that one, and then we're going to hit page to accept all the pre-configured channels. And then this just is telling you a review of what you've agreed to. You're going to hit long enter to say yes. All right, now we're going to go page past this. You can change the model name here if you want to. I'm going to press up to go to the very bottom of the list. We're going to keep scrolling up. The receiver that we have is a D8, channels 1 through 8, and then there's the bind button. To bind it, we simply just highlight the bind on the controller, hit enter, and it'll start chirping. Once that chirping noise can be heard, you're ready to simultaneously press and hold down this momentary switch and plug in a battery. Now, if you plug in the battery and you see this green light flashing, that means that it's not bound and you need to retry the process. So you'd unplug it, press down the momentary switch. While the switch is being pressed and held down, you plug it in. And then you should be able to let go, and the light should stay off at this point if it is bound. So then you unplug it, click out of bind mode, and then you should be able to plug this back in, and that light should turn on steady. That means that you've successfully bound the receiver to the transmitter. And we're going to page all the way over to the mixer. We're going to scroll down to channel 5. We're going to make this our ARM switch. So this is going to be our first auxiliary switch. Mix name, you can make this down. And so to select the source, you can either go through a list by hitting these buttons here once you enter into it, or you can hit enter and it starts blinking. And then I know that I want this SA switch over here to be my ARM switch. So I just flip that, and then it automatically detects it and sets it. And I hit enter again to accept, and I come out. And now, so that's going to be my ARM and disarm switch, and then I'm going to need my auxiliary 2, channel 6. I'm just going to come in here, and I'm going to do source, and I like to have this one for my flight modes. You can, of course, pick any switch you want to. You can do that. If you select it and you're like, oh, wait, shoot, I didn't want SB, I wanted SC over here, you can easily just click it that way and see how it, when it's blinking, it's trying to sense what switch you want, then you can set it that way. But for me, I like SB, so I'm going to select it again. I'll switch it back to SB. All right, and now we can go out. All right, now we've got all 4 channels for control set up for the 2 gimbals, or the 2 sticks. And then we've got our ARM switch on channel 1 and our flight mode switch on channel 2. And we should be able to plug it in and set up everything we need to in BetaFlight. All right, I've got the micro quad over by my desktop. I'm going to open up Chrome, go into my apps, open up BetaFlight, and now we need to connect the flight controller for the first time to USB. And we're going to go down here to Firmware Flasher. We're going to select SP Racing F3 Evo. There's a couple of these SP Racing. Be very careful that you click the F3 Evo. That's the one you want. Otherwise, you risk having to go into DFU mode and unbrick all this stuff. Just do that. And then you want the most recent stable version, which is the 3.0.1. Click on that guy. And then we'll just leave this full tip erase and manual baud. We'll leave those alone. Those are good. We come down here to the bottom, load firmware online. Once it finds the firmware and downloads it, we're going to go ahead and say flash firmware. And you'll see that this bar right here will tell you the progress of the flashing procedure. And once it's done, you can connect to the board. All right, programming successful. It makes a little USB noises, and we click connect. All right. So now we can see that the quadcopter is talking to the computer via BetaFlight. Perfect. Alrighty, so now we're going to go in here and we want to be able to communicate with the controller to the micro quad. So we're going to go into ports, and remember when we soldered in the tiny receiver into UART2. So we're going to come here and click on the serial RX for UART2 and then click save and reboot. Now this is really important. Every time you go into a new tab, fill out all the information on that one tab and then click the save button. Don't ever click on this tab, then come down here and click on that tab, and then go back here and click on that tab, and then click save once, because you're going to lose all the changes. BetaFlight only saves changes per tab. So I changed this one port thing. I'm changing UART2 to serial RX. I click save and reboot. All right, That'll reconnect. It'll pop back up. Now I'm going to go back and double check. Yes, UART2 is now showing that it was saved. Serial RX is now changed and turned on. Now I can go to configuration tab. All right, now that we're in the configuration tab, let's start over here. We'll go ESC. We don't have speed controllers. These are brushed motors. We want the motor stop on. So that basically means that whenever you arm the quadcopter, the motors do not start spinning. So we want that to be off. Let's see here. We want the minimum throttle to be 1,000, max 2,000. That all looks good. We'll scroll down. Quad X orientation. Yes, that's the frame that we have. Now this is what's really important. Receiver. We are doing serial-based receiver, and we're doing SBUS. We want these set up like this. Otherwise, the transmitter won't be able to talk to the receiver the way we have it set up. All right, we're gonna scroll down. VBAT, we'll leave that good. We want the battery warnings. We don't care about current meter. We don't have an OSD or any way of really reading that. 8 kilohertz for gyro, yes. And then the way my PID tune I've done for 4 kilohertz, so 8 and 4. Let's scroll down a little bit more. So telemetry is off, black box is off, transponder off. What I'm trying to do here is check off all of the things that I'm not using. That way we get a faster CPU load time, or I guess CPU load we want lower, and then we want a faster cycle time, if that makes sense. So I'm turning off all the stuff that we're not really going to use. So I'm done in this page, and so I want to click save and reboot before I go to the next tab. Alrighty, now we're going down to, we'll skip PID tuning for right now. We'll go to receiver, and you can see here that our quadcopter is wildly spinning out of control. And that is because the channel map is AETR. Now, that is not our channel map the way we have this set up. This is set up with the Gropner TAER. So once that's changed, we can click save, and bam, it locks in. Now look back over here. Our throttle is working, good. Our yaw is working. Our pitch is working. Our roll is working. That's all working beautifully. But our quadcopter is still drifting around and kind of wildly spinning. And that's because these are not zeroed out at 1500. So throttle you want all the way down. That should be a little bit closer to 1,000, but that's not really going to hurt anything for right now. Let's go ahead and get the yaw, pitch, and roll to as close as 1500 as possible. And the quickest, easiest way to do that is by using these trim buttons on the Taranis. And so you want to bounce that around and make sure that it, when it comes back to rest, it's as close to 1500 as possible. And there's always going to be a little bit of variability there, but you just want to try to, as quickly as possible, get it as accurate as you can without spending a ton of time. So now, that's pretty good. I'm happy with that. I'm about 1 off on these. So that looks good. So now you notice that the quadcopter in the corner is very much, it's still drifting a little bit, but it's staying put, and that's how we want it. Okay, so we'll go ahead and click save. Once again, it's just a good habit to get in to click save whenever you're done, you're ready to move on. And we'll go into modes. Oh, before we go into modes, sorry. So remember how I had us do the SA switch and SB switch over on the bench? Well, this is where it saves us some time. So if you look here, auxiliary 1, that's already set up and recognized here. And auxiliary 2, that is also set up and recognized. So now we'll go into the modes tab, and to arm it, because I wanted to use this one, we're going to say auxiliary 1, and notice this little yellow tick mark. It's going to move to here and then to here, representing the 3 different distinct positions on this switch. So I like to have it armed in the middle. So if I'm flying and I freak out, I just like hit the switch either way, I disarm it. So that is how I want the arm switch to go. And then we can also set up, if you would like, angle and horizon mode running off of the auxiliary 2 switch. So I'm going to go ahead and say angle mode, horizon mode like that. And then that way I can select the flight modes I'm in. And if you don't have a flight mode selected, so like in this case, I'm over here, and it's going to be armed, so it'll fly. And this is just pure acro mode. There's nothing going on that's going to, I guess, try to help stabilize. And usually you can do an air mode with acro, and sometimes people like to blend air mode with some other flight modes. I'm just saying this not to confuse you. Oop, we should do this with auxiliary 2. I'm saying this not to confuse you, but just in case like you're aware of these things and you want to figure out how to do them, that basically layers air mode on top of acro, or layers air mode on top of horizon, or if you want air mode on everything, you can do that, whatever. So that's how to do that. Okay, so now we want to save this the way it's set up. If you're happy, if you want to change it, you can, but you kind of saw how you adjust this stuff. We'll click save. Alrighty, now I guess we can go ahead and disconnect, and we'll plug a battery in and see if the motors spin. Let's do that. All right, now we're going to plug a battery in and make sure all the arming and motors and everything work. All right, so we'll see that the blue light is flashing. If we arm it, it should go to a solid blue light. There we go. You have to wait for a second for it to kind of chill out, and the blue light will turn off, and then when it turns on steady, that means that it's armed. Perfect. Okay, this is with the stock rates and with the stock PID values. I've done nothing but load BetaFlight and configure my controller to work with this. All right, so we're armed, and it should fly pretty well. Feels pretty good. Perfect. The stock rates and the stock PIDs are actually not too bad. They can be better, and I, for my own preference, have retuned it and played with the rates a little bit to get my controller to feel and get that control and that really locked in feeling. But as far as you know, just getting something in the air, this with the stock rates and everything is going to be good. I'm going to make the next video. Let's see, it's going to be over here, I guess. And I'll show you how to tune the PIDs and get the rates and all that stuff in BetaFlight fine-tuned. But I'll save that for another video because I've already covered a lot in this one. And at this point, you can fly this thing around and get a feel for, oh, okay, I think I want to do a PID tune, or I think I need to change the rates. And about that time, I should be releasing a video and help guide you to be able to do that. But for now, just rock this thing, fly the crap out of it. I want a lot of feedback telling me what I did good, what I did bad, what you do like about this frame. And I'm hoping that there's more good than bad, but we'll see. And I'm always willing to redesign or change some stuff on this if I need to. That does it for the electronics portion of the Mark 11 build series. Now, I hope you learned something in this video. I know I covered a lot of basic stuff for a lot of you quadcopter guys who know way more than I do, but I'm hoping that there are people that are just getting into this that don't know a whole lot, and I just want to make the process of building their own microquad as easy as possible. Also, I appreciate all the comments. Holy moly, that was pretty cool to see all the feedback that y'all gave me. The 3 lucky winners, if y'all will send me a private message through YouTube with your address, I'll be happy to mail y'all your frames. And as always, if you have questions or comments, leave them down below. Hit the like and subscribe button, and I will see you next time.
Ils seront dans le game.